Okay, so now we're going to take a look at a couple other examples of linear systems. Now, we're not actually going to solve these just yet. I just want to give you a chance to think about them on your own. But first, let's look at them first, and then I'll let you spend some time thinking about them. So, okay, we've got in example A here, we've got what? We've got a linear system. How many equations does it have? That's going to be one of the first things you notice when you look at a linear system. This one has two equations. Another thing you're going to be often concerned with is the number of variables. So how many variables does it have? Well, it looks like it's got three variables, x1, x2, and x3. And okay, well, how would you go about solving a system like this? You might ask the question, well, how could we solve it? There's more variables than there are equations. You might be used to the idea that such things are unapproachable, but they're actually not. We're going to come up with techniques to handle them. What is true, though, is there will not be an absolute unique solution to this linear system. It'll be impossible to force the variables to be particular values, all three of them. Because there's only two equations and three variables, it's quite possible. In fact, you almost expect it to happen that you're going to actually have, not only are you going to have more than one solution, but you might even have infinitely many solutions. Okay, and so we're going to come up with a systematic way to express such things shortly. But for now, I'm going to just leave that be, and I want to draw your attention to the next example. So we've got a linear system, and looks like there's four equations, and there's four variables. The variables are w, x, y, and z. Notice how this linear system's expressed. Look at the way it's written. It's very organized, and this is something that you're going to want to be paying close attention to whenever you look at a linear system that someone else writes down, but also when you write them down yourself. Notice that all the w terms line up perfectly. All the x terms line up perfectly, all the y terms and all the z terms, and how the equal signs are all perfectly aligned. That just makes these so much easier to read. You definitely don't want to have, like, say, imagine the first equation had negative 10w, and then instead of plus 3x plus 2y, maybe it went plus 2y plus 3x minus z. So in other words, pretend that I swapped the order of these two terms. It wouldn't really change the meaning, but it would make it harder to read, especially if the order of the other terms were mixed up as well. Imagine down here on the third equation, imagine that said, instead of what you see here, imagine it said 10z plus 4x minus w plus 5y. Well, technically that's the same thing as I've just highlighted here, but if you mess around with the order and all the equations no longer line up nicely, it makes them harder to read, and it makes it a lot easier to make errors. So protect yourself against that by, when you write down a linear system, make sure everything is lined up nicely. You'll notice that happens over here as well, right? x1 line up, the x2s line up, and the x3s line up nicely. Okay, okay, back to this example. How would you solve this? Could you use the substitution method like we used for the previous example? You actually could. It would be quite a bit more work, but it is possible to do it that way. But I'm not going to actually go through that right now. And in fact, we're not going to spend much time thinking about the substitution method in this course. It's good to think about it as a method that's available, but we're going to look at more efficient methods, because what you might have already guessed is that as your linear systems get more and more complex, like this one, for example, there's four equations and four variables, uh, it just gets unmanageable to solve these by substitution. We're going to need to have a more efficient and organized way to do that. And that's what we're going to see momentarily. Before we move on to that, I just want to run through what this exercise is asking you to do. So what does it say? It says use trial and error to identify a solution to each of the linear systems in the preceding example. So I want you to do that for both of these. And you don't have to show your work. You don't have to find it exactly. Just start playing around, right? So for example, can you think of three values that you could assign to the variables x1, x2, and x3 that would make both of those equations true simultaneously? And just, this is worth thinking about. If you and your friend both answer that question, you might come up with different values, but still both be correct. There's more than one answer to this question. There's more than one solution to this linear system. So how would you do it? If you're just looking at it very quickly and trying to guess at what the solution might be, what are some strategies? And this is not something that we're going to be doing all the time, but I want you to just think about this. What if I just said, okay, why don't I just assign the values 0 to x2 and 0 to x3? What would happen? Well, then the first equation, if x2 and x3 were both assigned the value of 0, then the first equation would really just be x1 plus 0 minus 0 is equal to 1. And the second equation would just become x1 minus 0 plus 0 is equal to 4. And I think that might get you a solution, right? And just let me jot that down too, so it's not, so I didn't just say it. I'll actually write it down. If I try, let's say I assigned the value of 0 to x2 and 0 to x3, then what would happen? What would these two equations look like? And I'll ask you to spend a few minutes doing that yourself. Okay, so I'll leave it there. And then one quick comment about the second one. You might think, okay, well, the second one is going to be much trickier because there's so many more variables, and there's 4 variables and there's 4 equations. It may not be quite so straightforward. I'll just give you a hint. Take a look at all the constant terms. Note that all the constant terms are equal to 0. You may be able to use that to your advantage when trying to come up with a solution here. Okay, so I'll leave the rest of that exercise with you, and this is something that applies to every time I give you a little exercise in the middle of the notes here. It's something I want you to try on your own, but it's not something I want you to spend hours and hours banging your head against the wall. If you try it, spend a few minutes on it, but if you get stuck, just reach out and ask for help, whether that be from me or from some tutoring services that are available on campus, or your friend, right? Or you can always come visit me in office hours or send me an email and I'll give you some advice. But for now, I'll leave it to you to think about this, but you can always come ask for help if you get stuck.